Okay, we're doing a 2-for-1 today because we didn't really finish acid bases. This one's gonna be super quick, but wow, I cannot spell trations, right? Very quick, very simple, very easy, or at least supposedly. But pH is always going to be on the Y, and is going to be 0 and up. And this is going to be the concentration of whatever is added, right? So the most standard one that we see is going to be the concentration of the base added, meaning that in our little beaker, right, in our little setup, we're going to have this guy. This is going to be base, right? And then in our little beaker, we're going to have an acid, right, with plus an indicator and whatnot, and we're going to be dripping the base into the acid. So concentration of base added, it's going to increase this way. And general rule of thumb is that these curves are going to look like this, right? A little stair step. And then there's going to be a couple of points on here that we need to know. We have to go with those, and then just for shits and giggles, we'll learn about those. This right here is going to be the equivalence point. This is going to be the half equivalence point. And this is going to be the pKa, right? And then this little section is going to be the buffer zone. Okay? And the buffer zone, because it's going to resist the change in the pH when you're adding the base. But then it'll get out of it and it'll shoot right on up there. But that's one example. The other example, we'll draw these ones small, but is if we add the acid, right? Acid added. And then this one's going to be pH over here. This one's just going to be the opposite way, right? Because we're going to have a base here instead of the acid, and we're going to be dropping acid in. Acids have lower pH, so the more acid we in, the more, right? Equivalence point, half equivalence point. You get the gist. And then we are going to have polyprotic, so we'll go back to this one, right? So concentration of base, pH, right? And since it's polyprotic from last episode, you know, because I made another one, right? That means we're going to have more than one proton to donate, more than one pKa, so that means we're going to have more than one half equivalence point. So we're going to go here and then shoot up a little bit and then go down here and then again, right? So these are going to be your two equivalence points, your two half equivalence points, half EQ point, and those are going to be respective pKa's for dissociation. And then just a quick reminder, pKa is going to be the concentration, right? pKa is going to, at this point, pKa is going to be equal to the pH, right? So whatever it is, it's going to be like right there. But it's also where concentration of acid and the concentration of the conjugate base are equal, right? And if we take this, plug it into Henderson-Hasselbalch, right, which was pH equals pKa plus the log of the base over the acid. Then this will be 1, and log base 10 of 1 is going to equal 0. So pH is going to equal pKa at that point. And how does this all work? It all works because of indicators, right? And these are lovely because they change color at their pKa. So when you're choosing one, you want to make sure that their pKa is in range of whatever you're trying to accomplish over here.